Hey guys, the objective of this video is to look at the triaxial test and compare it to the shear box test to see its difference. So a triaxial test, what we do is we have a cylinder of soil. So we have our cylinder of soil, and if I were to draw this in section, we would have, so this is our cylinder of soil. So I'm going to draw our soil in black. So our soil is sitting in here, and what we do is we subject this sample of soil. So the first stage is we subject it to water pressure. So we put water pressure all around it, which we call sigma r, the radial stress. So sigma r that way, sigma r, it's going all around the circumference of the cylinder, and we also have sigma r coming down because the radial stress goes above it. So we're getting stress all over our soil element from water pressure. We then come and we put a force on our sample. So now we have a force F which acts over an area. So this stress, we know that stress is equal to force on area, and we would have a reacting axial stress. So if we wanted to relate all these things together, we would say that the axial stress is equal to the radial stress, so for vertical equilibrium, plus this F on A. Okay, so the axial stress is equal to the radial stress from the pressure of the water, plus this force acting over the area. We're going to be using this equation in the next video. We're going to use it and we're going to discuss it a bit further. But just for now, we're going to get an appreciation for what's happening in the triaxial test. The triaxial test gives us strength in terms of principal stresses. So this is the triaxial. Compared to the shear box, which gives us the strength along a predetermined plane. Okay, so we saw that for the shear box, we had two boxes which slid past each other, and that was along a predetermined plane. But for the triaxial test, the strength is given in terms of principal stresses. So what we can do is we can construct a Mohrs circle, which is a graphical representation of the stress, the normal and shear stress at any point. So if we were to draw an axis, we would have a Mohrs circle. Let's call this sigma 3 and sigma 1. So sigma 1 and sigma 3 are the principal stresses. Those are the values we would obtain from our test, the principal stresses. So these are the principal stresses. And from these principal stresses, we can construct a Mohrs circle, which will give us, so this is sigma n, and this is tau, so this is the normal stress and the shear stress. So based on these values, we can find the shear and normal stress along any plane. So in a shear box, we could only find it along the one plane because we were shearing it just in the horizontal direction. So we could find it only along that plane. But from the triaxial test, we will find the principal stresses, which will allow us to construct a Mohrs circle, which will enable us to find the shear stress and normal stress along any plane, keeping in mind that the angle in the Mohrs circle is 2 times the angle in reality. So if I were to just conceptually show you what I mean, if we had, say, an element of soil, we could use a Mohrs circle. So from the shear box test, we'd only be able to find the shear and normal stress along that plane. So the normal stress and the shear stress. But from Mohrs circle, we can find the shear and normal stress at any orientation. So we could find it along there. So we could find the shear stress, sorry, that would be the shear stress and the normal stress. We could find it at this orientation, the normal stress and the shear stress. So the triaxial test doesn't give us the strength in terms of normal and shear stress along one plane like the shear box test. The shear box test gives us just the failure values of normal stress and shear stress just along the one plane. The shear box gives us the strength along the triaxial test gives us strength in terms of principal stresses, which we can represent on our Mohrs circle, which will allow us to construct a circle to determine any value of shear and normal stress at any plane. So you can see the huge advantage of the Mohrs circle, that we can rotate our element of soil to see the normal and shear stress at that point, and we do that by first finding in principal stresses. So in the next video I'm going to introduce you to all the formulas which will enable you to construct a Mohrs circle and enable you to do any question. Hope that helps.